Hi viewers. In previous video we saw one problem on mechanical translational system. Now we shall see one example problem on mechanical rotational system. So this is the problem given. Okay. So what he is telling, write the differential equations governing the mechanical rotational system. Obtain transfer function of system. In problem you should know what is the transfer function we should obtain. That means output by input. In mechanical translational system, x of s by f of s, right? In translational system, here angular displacement theta of s by t of s you should derive, right? So theta of s by t of s we should derive. So now let us see. Same as mechanical translational system, you should draw the free body diagram for J1 as well as free body diagram for J2. Okay. So for J1 what you are going to take? What will be the terms? Tj1, right? 1 Tj1, Tk, and you are going to have, this is the displacement theta 1 anyway given, and this is the torque. Okay, torque is given. So what will be the equation? See, in this side there is no torque. So while writing this side J2 equation, you should write like 0 is equals to. But for J1 you should write like T is equals to. So what the terms you have here? T is equals to Tj1 plus Tk. Only two terms. Same way in translational system, what we wrote, if you have the F is equals to Fm plus Fb plus Fk, like that we wrote, no? Same here, you have the torque. So T is equals to Tj1 plus Tk. Here theta 1 is the angular displacement. In mechanical translational system, x is the displacement. So T is equals to Tj1 plus Tk. So you know Tj1 equation what is? J1 into d square theta 1 by dt square. In first video I noted that. Again I will show you. See, Tj formula is j into d square theta by dt square. And same here Tj1 is j1 into d square theta 1 by dt square. Whatever the angle here, it is theta 1, you should write here theta 1, right? Theta is for j2, okay, in the middle. And what is k? K is between theta 1 and theta. And we are considering now the problem for j1. So you should mention like theta 1 minus theta. So Tk is k into theta 1 minus theta is equals to t. So take the Laplace transform. So what we discussed previously, Laplace transform is j into s square into theta of s. So as it is theta 1 of s plus k into theta 1 of s minus theta of s equals t of s. So here you can take for theta 1 of s and theta of s equals to t of s, right? This is equation you should mention. And again free body diagram for J2. What are there for J2? You should write. So Tj2, Tk, Tb. Tj2, Tk and Tb. Three terms you are going to get. And also here no torque is there. So you should write it as 0 is equals to. 0 is equals to. See what I wrote here. 0 is equals to. What are there? Tj2, Tk, Tb. 0 is equals to Tj2 plus Tb plus Tk. So as usual, J means J2 into d square theta by dt square plus B into d theta by dt plus K into, see what K now we are taking from J2 side. So you should write like theta minus theta 1 is equals to 0. So take the Laplace transform. So for J it becomes s square into theta of s. D theta by dt is bs into theta of s plus k into theta of s minus theta 1 of s equals to 0. So from this equation also you take common like theta 1 of s and theta of s. Separate the terms of theta of s and separate the terms of theta 1 of s. So our conclusion is you should write equation in terms of what? You should drag the equation theta of s by t of s. See, so what to do now? See, you have here one equation and here you have one equation. Either from this equation you substitute So either from this equation you make theta 1 of s is equals to, or from this equation you take, okay. So you take theta 1 of s is equals to this. So substituting theta 1 of s in our equation 2, you are going to get this form. Okay. So after calculation, theta of s by t of s you are going to get. Okay. So this is how to solve in mechanical rotational system. Thank you.